So now, starting the second video of profit maximization for chapter 8, we can just jump right in. So in profit maximization, firms are going to be facing two decisions, essentially. They are going to be facing how much, or what output level should we be producing, and we're going to be producing at Q star to maximize profits or minimize our loss. And there's going to be three ways that we're going to be able to do that. We're going to be able to, one, set its output where our profit is maximized. Very simply, like I know that that seems like straightforward. Two, we're going to set it where our marginal profit is equal to zero. Three, we're going to set it where our marginal revenues are equal to our marginal costs. So our marginal revenues are equal to our marginal costs. And then the second decision that we have is this shutdown decision. So is it more profitable to produce at that output, or should we just close up shop and leave? And so this graph will show us the output rules 1 and 2, right? So if we remember, output 1 says that we should set our output where our firm is maximizing profit. And so this just means that we are going to set at which this graph is at the top. The other thing, right, is like so setting it here. The other thing is that we want to set where our marginal profit is equal to zero. And if we think about this, these are essentially saying the exact same thing. In order to find, to find max pi, you need when d pi dq is equal to zero and the second derivative is less than zero. Right? And that's just the second derivative rule for optimization. We should have learned that in Calc 1. But that is output rule 1 and 2, right? So essentially, we're just trying to find the peak of this hill. And if we're able to find the peak of this hill, then we should be able to figure out where profits are maximized. Now, mathematically, this can look a little different, right? So at the optimum, we have this profit equation. And at the optimum, we said that that derivative, or that marginal profit with respect to Q, should be zero. And so what does this actually look like? Well, if we took dq, d pi q, dq, that would be the same thing at Q star. That would be the same thing as taking dr, dq star, dq, minus dc star, not c star, q dc of q star, dq. And both of these are when our marginal revenues and marginal costs. So this is marginal revenues, and this is marginal costs. If that's equal to zero, then we know that marginal revenues must be equal to marginal costs. And so what does this mean? If we think about this intuitively, by saying marginal revenues are equal to marginal costs, we are saying that we are going to produce up till the point until when we produce one additional unit, the extra dollars that we receive in return are going to be just offset by the cost that it is like to produce it. And if we remember, perfect competition says that we should not be making any profits on the margin. And so when we're not making any profits on the margin, that's going to be a really easy way for us to notice that we have all sorts of, that we are just working where marginal revenues are equal to marginal costs. So in the short run, remember that these are going to be equal to P. And if we think about how this profit equation looks in the short run, we have P times Q minus C of Q. Taking this derivative is going to give us P minus marginal costs, which are equal to zero. And so our marginal costs should equal P. But by definition, our marginal revenues are also going to equal P. So in the short run, just replace that revenue curve with P times Q, and we should be good to go. So let's do an example. I think this would be, we've been able to follow pretty well so far, but I think that we like doing an example would just kind of iron it home. So suppose that our firm's production function is listed like this. So this yellow part is going to be our revenues, and this red part are going to be our costs. So we need to find Q star, R of Q star, so Q star, our revenues, our variable costs, and our profit at that optimum. So to find Q star. Remember, marginal revenues need to equal marginal costs. And so if we take marginal revenues, so marginal revenue of Q would be DRQ DQ, which should just be 80. And marginal costs should be DCQ DQ, which should equal 40 plus 20Q. And so that means our Q star is going to be 2. So throwing this back into the revenue function, right? So R of Q star is equal to R of 2, which we said was $160. Then our variable costs of Q star is going to be our variable costs of 2. And if we remember this, this is going to be F plus VC of Q. And so everything that has a Q is going to vary with quantity. And so that's going to be our Q star. And so this is going to be 40 times Q plus 10 times Q squared, which is 120. And so to put this all together, our profit at the optimum is going to be 160 minus 90 plus 120. And so our profit is actually minus $50, which sucks. But sometimes that's just how it works, right? Sometimes this might be like a build-up period, it might be something, but sometimes it just sucks. So now let's do a second type of question. So the following cost curve for a firm in a competitive industry with P is equal to $150 is costs are equal to 1/3 Q cubed plus 6Q plus 150. So first, let's find MC. Well, that would just be Q squared plus 6. And what is the profit maximizing level of output? Well, if we remember, in a competitive industry with P equals $150, that means that our marginal revenue should be our marginal costs, right? But also, in the short run, that should also be equal to our P. And so if we set this marginal revenue, our marginal cost equal to P, so then we've got Q squared plus 6 should equal 150. That means that our Q star should equal 12. And so then if we knew this, our profit function would then be something like 150Q like something like that. And so our profit maximizing price, this is kind of a trick question, is going to be what the competitive industry offers. Because again, we want our marginal revenues to equal our marginal costs, and that is at when P is equal to 150. And so our firm's profit at this point is going to be this long-winded, which is going to be minus $348. And so that would be this great grand example. And so that's it for this second video. We're kind of flying through these videos, so we might be done. This might be a pretty short week. And so video 3, we're going to be talking about competition in the short run. And then I've decided that we're really not going to be focusing on the long run a ton in this video, or in this chapter, or for this like section. So read the chapter. I think it'll be very good, but just skim it. You'll be fine. Um, yeah. So that'll be the end of video 2, and I will catch you guys in video 3.